Hello everyone and welcome to this cloud coaching session as part of Modern Data Platform series, and today we will be talking about the manufacturing industry. My name is Rakesh Chhoria. I am part of the EMEA Analytics Specialist team and I live in Bangalore, India. Today's agenda would be we will talk about the manufacturing industry, the kind of transformational journey that this particular industry is in today, and what are the common use cases that we see. And we will also talk about one such use case in detail, that is about predictive maintenance. So manufacturing industry, as I have said, right, due to the recent global events, be it the disruptions caused by COVID-19 or the latest geopolitical crisis that has come up due to the geopolitical crisis in Middle East and Europe region, global supply chains have been disrupted, and manufacturing industries are figuring out how to handle these crises better so that at the end of the day their consumers do not suffer. Okay, so as a result of this, they are driven to take this transformational journey where data is at the heart of this transformational journey. So some of the use cases that we see in manufacturing industry today would be, say, for around supply chain, it would be something like transport management, warehouse management and optimization. Even something like a supply chain visibility is needed today. Okay, on operational KPIs, we see things like tracking the performance KPIs, and be it predictive maintenance, plant data consolidation. These are some of the common use cases. Now, on the sustainability front, again, sustainability is a very important aspect for all of the industries in general and manufacturing industry in particular. So some of the new use cases that have come up are things like CO2 reductions, water reductions, heat efficiency, and things like even waste reduction or waste removal from the entire manufacturing process. On top of it, health and safety has become a major thrust area especially after the COVID-19 disruptions. So now new use cases like safe working compliance, things like accident root cause analysis, these are the new use cases that have come up as part of the manufacturing industry. And we would like to say that Oracle Modern Data Platform as a data platform caters to almost all of these use cases, and we have actually capabilities. The platform has the capabilities where you can use the capabilities and build these use cases. So one such use case that we would like to show the demo today is what we call as predictive maintenance. So as part of this predictive maintenance use case, what we would like to talk about is, first we will look at the financial KPIs of an organization to look at the health of the organization. And when we see that one of the KPIs, the operating expenses, is not performing as expected, we analyze it further, drill down, and try to identify the root cause of why this KPI is not performing as expected. Now, once we have identified the root cause, what should be the next steps? Because so far what we have done is we have just identified what has happened, right? So this is where the machine learning capabilities of the modern data platform will help you to build machine learning models and even predict, say, such scenarios in future, and then you can be better prepared in terms of how to handle these scenarios if they happen, or even prevent such scenarios. Okay, so predictive maintenance would be a use case where you are trying to preempt a scenario where if a breakdown happens, you would have to handle it right after the breakdown. How you can use the machine learning model and the insights that it generates and actually prevent that breakdown from happening. Okay, so with this, let's deep dive into the demo that I will show you in just few moments. This demo is divided into two parts. In the first part, I'll walk you through the Oracle Analytics Cloud's interface and UI and show you some of the key features of Oracle Analytics Cloud. So some of the key features like the search capability, the data preparation and data enrichment capabilities, and then how easy it is to use the UI and build workbooks very quickly, and also a use case where I'll show you how you can build a machine learning model. Okay. And in the second part, we will talk about the predictive maintenance use case dashboard that we have prepared. Now to start with the search facilities, say I am on the home page and I quickly want to see the sales. So I can type in something like show me sales by city and product category. So now the moment I give this search, I actually get visualizations on the home page itself, where based on a particular data set that is available in the Oracle Analytics Cloud platform, I see the visualizations here. Okay, so this is how powerful the inbuilt AI ML capabilities of Oracle Analytics Cloud are, where you can just key in with keywords and you'll get visualizations generated on the home page itself. Now the second key feature would be around data preparation and data enrichment, where if I have to navigate to the data tab, so these are the different data sets that I have when I did a key search with sales, right? So I'll use one of those data sets and show you how it works. So this data set is actually containing a set of attributes or columns, okay? And on the right hand side, what you see is that once the data set is uploaded into Oracle Analytics Cloud, the system would actually do deep data profiling and provide you these statistics for each of the columns that have been loaded, and it also gives you certain recommendations for enrichments. Okay, so some of the recommendations that you see here are actually around the date column, date attributes, right? Say something like if you want to extract date, say you want to extract the year, quarter, month, or maybe day of month, day of year, you can do that just with the click of a button, where a new column will get added with the extracted value. So in my case, if you can see here, using the same enrichment capability, from the date I have extracted the month, the quarter, as well as the year columns. Okay, so this is one form of data enrichment that can be done. Okay, now apart from that, say I want to add a new column based on the sales, right, or the count of sales. Okay, so I want to create a binning of this particular column. I can do it on the fly, where say I'll say create a bin. Now what is happening is, by default the system has analyzed the data and given me a bin combination of 4 different bins. Okay, and it has given me ranges also. Say I want to go with not 4 but 3, I can override it. Okay, and now I want to say give my own values and say 1200 to 2400, and then greater than 2400. Now if I want, I can override this also as sales volume category. Okay, so I can give a name. Now once I click on add step, now this new column has been created and it has been added to the data set. Now all I have to do is I have to just click on save. Once I save this new column is now available for usage in workbooks, and I can do the analysis. So these are how easily you can upload a data set and then do a lot of data preparation and data enrichment activities. Now with this, what I'll do is, now I'll show you, once you have uploaded the data set, now say you want to do your analysis, you want to create a workbook. So this is how the interface would look like. So on the left hand side, you see you have the data set with all of these columns, and you see that we have also the new column that we just created. And if I want to quickly do some visualizations, I'll just do count. Okay, so this is how the count looks like. I want to maybe change the number format, where I'll just say it is number, but I want an abbreviation with 2 decimals. Okay, so this is how the sales would look like. And then say I want to do the sales by date. Okay, I'll say create best visualization. So now, as a visualization for time kind of things, line graph is the best. Now to this, I would like to add some advanced functions like say trend line or forecast, right? If I have to do, I can add a trend line. Now once I add a trend line, I can see that it's a sloping upwards trend line, which is good. This means that there is an increase in sales over a period of time. Now there are different trend line options that are available. You can go with linear, exponential, or polynomial based on the nature of the data set. Now on this, if I would like to add a capability, say I want to do the forecast, I can do the forecast by just clicking on button to add forecast. Now with this, what is happening is, it is actually generating the forecast for next 3 days as of now. And the models, again, the system supports 3 different models: seasonal ARIMA, and ATS. Okay, now based on the data set, now here maybe I want to do the prediction for next 60 days. Okay, so I'll just enter the period as 60 here. Now once that is done, the system is actually doing a forecast for the next 60 days using seasonal ARIMA. So as you can see here, as users, I can actually generate these advanced analytics functions also without having the need to write any code. It's just click and configure. Okay. Now, one important feature of uh, Oracle Analytics Cloud is the capability of auto insights. So by auto insights, what I mean is once you upload a data set into the system, then the system, apart from doing the deep data profiling, it also does semantic analysis, and based on the semantic analysis that it does, if it identifies some interesting visualizations based on the cardinality of the attributes and also the measure values, maybe the range, the band of the values, right? And it will actually generate some visualizations which the system thinks are of interest. Okay. And the good part is for each of the visualization that is generated, it also gives you a description. Okay. So here you can read the description, and then if you think that this visualization makes sense, I'll just add the visualization here by clicking on this plus sign. Similarly, I like this heat map. Now for demo purpose, I'm just adding randomly a few of the visualizations that I have here. Okay. So with this, now I can see that I have a canvas now with number of visualizations added. Now another good part of this auto insights feature is when you add visualizations to the canvas, if there are any calculations that are done to generate these visualizations, those calculations get added to the workbook. So now these are reusable. You can use these calculations in creating new visualizations within the workbook. Okay. So if you want to look at it, this is how the calculation is defined. Now this is created for you by the system. So in this way, this is how easily you can actually use the UI and create visualizations, be it simple drag and drop, or you can use the auto insight capabilities of the platform to generate these visualizations. Okay. So next key feature that I would like to talk about is how easily you can build a machine learning model. Okay. So now let's use this sales data itself to build a machine learning model. Typically what we do is when we have historical data of sales, we usually divide it into two parts. One is sales data for training and the other is for, say, prediction. You want to use it to predict. Now in our case, what we do is for training data, usually you take a representative sample. Okay. So in my case, I have the sales data for training here. What I'll do is I'll use a feature called data flow, and as part of the data flow, I'll use the sales data that I had created for training purpose and then use it and build a machine learning model. So the data that you see here is the same sales data for training. Now here, as users, you can actually have different steps that are available. So again, it's a very easy to use UI where you can drag and drop steps and create your own definitions, transform columns. You can merge, join, group, all of those functions are available. And even you can build machine learning models. Okay. So in this case, what I have done is I have used the day column and I had derived the month, quarter and year from the date column itself as part of enrichment, right? So what I have done is I have removed these three columns from the model building exercise. Now, once I identify, okay, these are the columns that I need to build the machine learning model, the next step would be to add a step that would actually create the machine learning model. So in our use case here, we are trying to predict the sales for future. So for this, we will use the train numeric prediction. So in case you have a use case where you want to do, say, a classification problem, we actually support binary as well as multi-classification model building. And in some cases where you need unsupervised learning, we also provide support for clustering model as also. Okay. So in our case, coming back to this sales ML model for prediction. So here you can see that we have selected the train numeric prediction. And as part of this particular task, there are 4 different ML algorithms that are available out of the box. Be it elastic net linear regression, random forest, cart, and linear regression. So for our use case, we are using linear regression. So next, what we need to do is we need to provide the column on which we are building a machine learning model. So in our case, we are trying to predict the sales. So we will use the column count. So this is the model on which we are trying to generate a machine learning model to do the prediction. Now these all parameters, you can leave them default now for first iteration. Okay. All you need to do is you need to give a name for this particular ML model, save and run the data flow. Once the data flow is run, then you will have the machine learning model ready for your testing purpose. Now to test the machine learning model, all you need to do is, again, in a data flow scenario, you can have now I have the sales data for prediction that I want to use. I want to use this data to do a prediction. All I'll do is I'll select, say, apply model. I'll select the machine learning model that I want to apply on this data. And as a result of this ML model, what you are getting is you will get one new column generated, which is called as predicted value. I have just renamed it as predicted sales. Once this is done, I'll actually give a name to the output and save this data set. Now, once I again save and run this data flow, I actually now have the sales predictions for the future, say 6 months of data that I have here, right, which I've used for prediction. I would have the sales available, which I have generated using the machine learning model building. So as you can see here, this is a very easy way to build a machine learning model and then use it for your analysis to get more insights. And again, no need of any coding or any complex SQL writing. All of such things are not needed. So now that we come to the end of the first part of the demo, where I've shown you some of the key features of Oracle Analytics Cloud, now let's move to the second part of the demo, where we will talk about the predictive maintenance use case. Now let's look at the predictive maintenance use case related demo. So as you can see here, this is the main KPI dashboard that we have, where we are tracking the key KPIs such as revenue, operating expenses, net income, payables, and receivables. So at a high level, these KPIs look okay. So the revenue is 1.66 billion, operating expenses are close to 658 million, net income is 118.3 million, payables 147, and receivables around 980 million. Okay. Now when we drill down a little further, what we see is the revenue, again, it's little up and down month on month. There is a lot of variation, but overall it's looking okay. But when it comes to operating expenses, we see that right from the month of January all the way to December, we see a steady increase in operating expenses. And these are the predictions for next 3 months. Okay. Now, as you can see, because of a steady increase in operating expenses over a period of time, we see a gradual decrease in net income, and where for the month of December, actually we see that we have a loss. So as a loss, so this data point is highlighted, and it is also possible that you can add some notes or annotations and link it to a particular data point. So in this case, I have added a note and mentioned that there is a negative net income. Okay. So as you can clearly see, a steady increase in operating expenses is what is causing the net income to decline and maybe even leading to a loss for a particular month. Now in this scenario, what can we do? To analyze further on this operating expenses, what I have done is here we have created a visualization where we are trying to compare the operating expenses for the current year, comparing it with previous year for 5 of the manufacturing plants that we have. So we have a manufacturing plant in France, Germany, Romania, Sweden, and UK. Now when I do the comparison of the operating expenses at the plant level, we can clearly see that for UK, the current year's expenses are much higher when compared to previous year. Whereas for the other 4 plants at 4 different regions, they are more or less in line. So either they are less than the previous year or maybe slightly higher than the previous year. So now with this insight that, okay, it could be the UK manufacturing plant where there are some issues and there are increases in operating expenses that could be leading to this decline in net income, right? So now we would like to do actually some more analysis on this particular UK manufacturing plant. Okay. So for this, what I've done is I have created a data action where you can select a particular country and then you can actually navigate to that. So in Oracle Analytics Cloud, we call this feature as data actions. Now here what you see is actually a KPI dashboard now for UK plant region. As you can see here, a filter is applied now for the UK plant region. Now these are the KPIs for this particular plant. Again, we clearly see that operating expenses are higher, especially in Q3. And we see that for this plant itself, at this particular plant level, we even see a net income turning into a loss. So we have experienced a loss in August itself. So in Q3, we have seen a sharp decrease in net income for this particular plant. Okay. Now to do little more analysis, while we have seen the KPIs at a annual level, right? Now when we do the comparison quarter on quarter, say current month operating expenses with previous month's previous quarter operating expenses of the previous year, we see that for this particular plan there is a steady increase. Q1 and Q2 it is less, but Q3 onwards we see a steady increase in the operating expenses. Now the next level would be, okay, from a time perspective, we see that Q3 could be a quarter where we see an increase in operating expenses, and as a result there are issues with the net income. Now let's drill down little further on the operating expenses and see how are they looking by cost center. So what you see in this visualization is the operating expenses over quarter on quarter for the different cost centers. So here we see that for sales it has gone up in Q3 and then a decrease in Q4, whereas plant and operations is actually another one where we see a increase in Q3 and Q4. Now if we look at the operating expenses by account group, clearly we can see that there is one particular account group called as operations and maintenance, where we see a steady increase in the operating expenses right from Q1 to Q4. Okay, and these expenses have not come down. So clearly this gives us an insight that there is something that has happened in this plant where these operating expenses are increasing gradually. It doesn't look like one-off. It has started increasing and gone beyond a point in Q3, and then it is increasing further. Okay, so this is a problem that needs to be addressed. So in this scenario, what happens is, usually you will look at the data, and now the next thing you would like to do is you would like to maybe compare this operating expenses KPI with the budgeted numbers. So in any financial analysis, actual versus budget is a very common analysis that we do, right? So in this case, what we will do is we will check and see how are the operating expense numbers looking when compared to the budgeted numbers. So again, clearly a similar picture where we see that for the first 6 months, we see a positive variance. We see a positive variance where the actual expenses are less than the budgeted numbers. But starting Q3, which is July onwards, we see a negative variance where the actual expenses are much higher than the budgeted expenses. And now here again, when we do the split from say quarter on quarter comparison that we did in the previous canvas, here you can see that we are trying to do the month on month operating expenses comparison, okay, for the operations and maintenance account group, because that was one of the account group that we identified as one where there is a steady increase in expenses. Now here what you see is a line graph which is actually giving the budgeted numbers. So clearly we can see that starting August onwards, the current month operating expenses for this particular account group have actually gone up much higher than budgeted numbers, as well as the previous year same month numbers. Similarly, another account group is travel and employee expenses, where we see that the expenses are high in August and September when compared to the same month last year, or as well as compared to the budgeted numbers. Now when we drill down a little further on this travel and employee expense, we have noticed that there are various subcategories like say hotels, the per diem that is paid, airfares and all. And one of these subcategory, hotels, and that too, these expenses are of out of policy nature, okay, where we see a sudden spike in the month of August. So as you can see, all of the data points in this particular canvas are pointing to that there have been some issues at this particular UK plant in the month of August, because of which the operating expenses have shot up. And also we see that there have been a lot of out of policy expenses that have happened, especially for hotels. So this clearly points to a direction that there are some issues for which maybe employees have had to travel to this particular plant to handle those situations, right? So far what you have seen is we started with a very high level KPI. We looked at the different KPIs like revenue, operating expenses, and then we drilled down further when we found an issue with an operating expenses KPI. And now upon drill down and getting new data sets, we have identified that at a particular plant, UK plant, we see that there are issues, especially in the month of August. That is where even employees had to travel to handle those issues. Okay. Now, so far the data that we have seen is actually coming from these two data sets. Okay, so one of the data sets is around the finance data and the other is around the expenses data. So here, as you can see, I have brought the data set from two different systems. One is finance, one is expense system. You can still combine and generate these insights here. Now, to take this use case forward, as we now understand that, okay, there are some issues at the particular plant, right? And especially around operations and maintenance. So now usually what happens is the data of this nature, the plant operations nature, usually you will not find it in an ERP system, right? It could be a separate system, sometimes custom system, or sometimes some other solutions developed. So even in this use case, we have assumed that this data doesn't reside in an ERP system, but in a separate system. So what you see here as these five assets, these five data sets, EM asset, FA, work order, inventory. So these are the data sets that contain the data about plant operations. Okay. Now, one good part about Oracle Analytics Cloud, especially when you do these self-service visualizations and analysis, is that you can actually bring disjoint data sets into the system and still do your analysis. While there is no relation between the data sets directly, say between finance data and say an asset data, okay, there is no direct relationship. Still, you can bring these data sets together and do a logical analysis. Okay. So now with this new data that we have now brought in for analysis, let's look at the plant operations data and how does it look like. So clearly we see that at this particular plant, we are having a backlog of 15%. And in this plant, we have already done a preventive maintenance of around 239K. Still, there are breakdowns that have happened and we had to spend around 437K to handle those breakdowns. So as a result of these breakdowns and backlog, we see that the inventory value is very high. It's close to 2.02 million. And another important KPI is what we call as mean time between failures in days. So at a KPI level, it looks like the value is around 26.9 days. So that means there are the mean time between two failures is 26.9 days. Okay. At a initial look, it looks very low, right? It looks like the breakdowns are very frequent. So to analyze further, what we can do is we can check at how this KPI is performing over a period of time. So here you see that 6 years ago, this number was actually 38.33 days. And then over a period of time, it has drastically reduced. And for the last year, it was actually less than 20 days. So it is around 19.5 days. So clearly, you can see that this KPI has been performing not good over a period of time. And we are seeing frequent breakdowns that are happening. Now, another part is because it is a manufacturing plant, right? So there would definitely be equipment and equipment related data. So the next analysis we would logically try to see is what is the equipment or what is the nature of the equipment? What are the asset types that are actually breaking down? So in this visualization, table visualization, what you see is that we have different asset groups or equipment groups. Okay. And what is the actual maintenance spend that we have done versus the estimated maintenance? Okay, so when we did a preventive maintenance, right, what is the estimated maintenance? So clearly we see that there is one particular asset group called CNC asset group where the actual maintenance cost is much, much higher. Okay, as a result, and this equipment could be the one where there are these breakdowns that have happened, say in the month of August, and to handle it is where we had to spend most of the time. So now let's look at little more details about this particular asset. Okay. So when we see this, so this is again an interpretation of the different KPIs, the mean time between failure, mean time to repair. So once this equipment breaks down, the mean time to repair is close to 2.86 days, which is not a good sign again. So it means once there is a breakdown for close to 3 days, there is no work that is happening because manufacturing has stopped. Now another very interesting feature that we have as part of Oracle Analytics Cloud is the usage of digital images as map background layers. So in this particular visualization, what you see is we have taken a representative manufacturing plant, image of a representative manufacturing plant, and then on top of it, we have overlaid the various assets data. So where they are located. Okay. And then once this is these two are combined, you can now see a very interactive visualization similar to how you would see on a map. So this is there is this option where you can use digital images as map backgrounds. Now for this, what you have to do is you have to upload the image into the system, into Oracle Analytics Cloud platform, and then have a layer defined on top of it. Now this layer can be drawn freehand, or if you have a GeoJSON file where you have defined this map layer, you can upload that GeoJSON map layer file into the system and then use the GeoJSON defined map layer and the image to create this visualization. So now the asset that is of interest for us is the CNC asset, and we can clearly see that it is located at this part of the plant. And these are the KPI related details that we see. So as you can see, bringing data from different data sources, different systems, we can still bring the data in one workbook and do our analysis. Although logically they are separate, still it gives a very good picture because we started with a very high level finance KPI. From there, we have actually drilled down, identified issue with some of the account groups, and maybe even we identified some of the subcategories of expenses. And then now we also have the plant operations data where we clearly see that which is the equipment that is breaking down and where is it located and what is the mean time to repair, and all of those KPI data we can get it. Now with this information in hand, the logical next step would be to see what are the reasons for these breakdowns, right? So for this, what we have done is we have assumed as part of this use case that the asset that is breaking down, there are sensors on this particular asset and we are collecting sensor data. So what you see is now a new data set that is added into the visualization, which actually gives you the sensor data. So for our use case, we have taken the date and we are capturing 4 different parameters. That data is coming from the sensors. So we are monitoring the pressure, the RPM, revolutions per minute, the operating temperature and the bearing temperature. And we are also getting a machine status. Okay. So now using this sensor data, what we will do is we will analyze the data that we have for this particular asset from the sensor data and see what is happening. Okay. So clearly we see that from the data itself, that mean time to repair is again 2 days. We have entries for around 1981 data points that are available as part of the sensor data, out of which there are 287 records where the sensors have logged that there is a breakdown. So the percent of breakdowns comes to 14.5%, which is very high. Now here what you see is actually a pivot visualization where we have tried to add a heat map effect, where you can see that we have used the status of the machine and the month of the year. Apart from that, we are tracking all the 4 parameters and we are giving the color based on the operating temperature. And again here we can clearly see that July and August months are the months where we see that there are maximum breakdowns that are happening. So here you can clearly relate to the financial KPI impact that we see in Q3, especially in August, to this particular asset breaking down, and even the sensor data giving us this kind of insight that July and August are the months, especially August is the month where we see that there are a lot of breakdowns happening for this particular equipment. Now that we have some data around the sensors, okay, sensor and the various parameters, now we did some analysis to see what kind of insights we get, especially on the values of these parameters that we are tracking. So for pressure, so the average value is around 3632.68. But one interesting thing to see is when the machine is working, the average pressure is around 3500, okay, whereas when the machine is broken, it's close to 4400. Similarly for RPM, we see that when the machine is broken, it's around 4022, when it is working 4031. So we don't see much of a difference. So maybe this parameter is not impacting the equipment's behavior that much. Okay. Now the third important parameter is the operating temperature, where the average temperature is around 96 degrees. And we clearly see that when the machine is working, the temperature is around 94.75 average. And again, when it is broken, it's 103. So clearly we see that higher the operating temperature, the chance of equipment breaking down is higher, which is not a good sign for us. Okay. Similarly, we can see a clear relation for the bearing temperature also. So with these insights now, we clearly see that the parameters have a role to play, and based on the data we collected, we can clearly sense that maybe there are certain ranges for these parameters where if those ranges are breached or they are crossed, then the chance of equipment breaking down is higher. Okay. So even now what we see so far is what we call as descriptive analytics. We are just using all of the data that we have at hand, trying to maybe identify the problem first and then explain it with reasons and identify the root cause. So now we can say that we have identified the root cause where for this particular equipment, maybe the parameters, especially say the operating temperature, could be one of the parameters where an increase in temperature is leading to the breakdown of equipment. Now, how about using the machine learning model building capabilities of the modern data platform and see how these parameters actually impact, and can we find something more additional information about these parameters and sensor data. So for this, what I'll do now is I'll walk you through the process of how you can use it to build a machine learning model. So again, in the earlier part of the demo, I have shown how you can do a numeric prediction, right? So now we will talk about a use case where we will do a classification problem. Okay. So as you can see here, I have the sensor data here with the status. Okay. Now in this case, my problem statement or use case is that I want to predict whether a particular equipment will fail or not based on the data entry, right? So for this, again, I'll use trained binary classifier. Now again, as part of binary classification, there are 6 different machine learning algorithms that are available out of the box. For this use case, I have chosen SVM for classification. Okay. So the next part is on the target. So I want to give machine status. Okay. And what is the positive class in target? So I have 2 values, 0 and 1. Okay. So I have selected 0, which means that the machine is working properly as the positive class. Again, I can leave all of the other parameters as default for now. Okay. And I'll give a name and a name for this model, save and run the data flow. Once the data flow is run, I will get a prediction, right? When I apply this machine learning model on, say, additional sensor data, I can find out whether a machine will break or not. But in this situation, I also want to know maybe what are the key drivers that are impacting, and maybe if I can come up with some rules around those parameters and their ranges, right? So in this case, what happens is once I have the machine learning model built, I'll just go quickly and inspect the machine learning model. Okay. So what I see here is, again, because I have run this model few times and I've done iteration, you see that the model accuracy is almost 100%. In a typical scenario, you will get something around 80-90 as the model accuracy, which is considered as okay for machine learning model building. Again, as I was telling, right, prediction is one part. The other part is I want to identify the key drivers and maybe identify those coefficients, right, of dependency, whether there is a positive correlation or a negative correlation with parameter, and maybe identify those coefficients which I can use and then come up with some rules for predictive maintenance. So in this case, I'll use the drivers dataset. Now in the interest of time for this demo, I have used this drivers dataset and built a visualization. I'll just quickly show you that. So here you can clearly see, so asset, sensor, SVM, model drivers. So this is the data set. Usually it has these columns, driver, coefficient and correlation. Okay. Now what you see here is the visualization where you can clearly see that the operating temperature has a negative correlation, because higher the temperature, the machine actually, the chance of machine breaking down is higher. Okay. And we had mentioned that machine status working is a good scenario. So in this case, there is a negative correlation with operating temperature. And now using this coefficient, say we come up with a rule that if the temperature goes above 96 degrees, okay, then the chance of equipment failing is much, much higher. So in this scenario, what we can do is we can set up now a predictive maintenance rule saying that we monitor the sensor data continuously. And if the operating temperature, say, reaches around 95 degrees, Okay, that is when an alert needs to be sent to the maintenance team, where a technician would come in and check quickly what is happening and maybe do the needful so that the temperature doesn't cross 96 and beyond, and the chance of equipment breaking down is minimized. So this way you can use the capabilities of Oracle modern data platform and actually build these machine learning models, come up with new insights, and then set these rules for predictive maintenance, and you can maybe minimize or avoid the breakdowns that are happening. And by the way, these breakdowns are actually impacting the financial KPIs at the end. So as you can see, we have brought data in this workbook from various systems, starting from finance to expenses data, then the plant operations data, then we also got the sensor data for this particular asset, and then after we build a machine learning model, we could also add the data set of the ML model itself to do the analysis. So this way, Oracle Analytics Cloud and Oracle Modern Data Platform gives you these rich capabilities using which you can come up with these new insights, build machine learning models very easily, and then try them out, test them out, and then once you have these insights in place, you can actually set up rules for predictive maintenance. Now that we have come to the end of the demo, I would like to quickly summarize some of the key capabilities of Oracle Analytics Cloud in particular that I would like you to take with you after you are done watching this video. And then if you have further questions, you can definitely reach out to the concerned people. So to summarize, Oracle Analytics Cloud as a platform provides capabilities for each of the three categories of analytics: governed analytics, self-service analytics, and augmented analytics. So by governed analytics, what I mean is these are those typically enterprise-wide used reports and dashboards that are generated on top of a data warehouse, and usually you would have a semantic model layer. Okay, so this kind of reporting caters to the requirement of one version of truth. Okay, so we have the capability to build dashboards, to define semantic models. We can also do data level security and role-based security as part of the governed analytics. And we also have a component called as publisher, which can be used to generate pixel perfect reports. So by pixel perfect reports, I mean that if you have any reports which are in the form of statement where you will have a company logo, maybe a company address and some text, and then a table or maybe a set of visualizations of data, right? So these kind of statements can also be generated using the component called BI Publisher. The second category was self-service analytics, where as part of the demo today, you have seen some capabilities around data preparation, data visualizations, and some sort of what kind of analysis, slicing and dicing that you can do with the product. When it comes to augmented analytics, again, we have capability to define machine learning models in a very easy to use UI. I showed you one example of how you can do a build a numeric prediction machine learning model for sales data. You can do data enrichments. Okay, we also have the capability around natural language, so where you can type in keywords and visualizations will be shown on the home page. We also have a natural language generation option, okay, where for a particular visualization, if you want to generate a description of it, you can do that. Okay, we have seen capabilities like auto insights. Okay, again, explain is one variation of auto insights, where in explain you select one attribute or measure and say explain this to me, whereas in auto insights, as I showed you, you can the system would generate visualizations based on the semantic analysis that it has done on the data set and then provide you with interesting visualizations. So with this rich set of capabilities, again, from a connectivity perspective, we support out of the box 35 plus native data connectors. Okay, we are available with Oracle Analytics. So with this complete all-round capability around all of these analytics, be it governed, self-service or augmented analytics, we can clearly say that Oracle Analytics Cloud is one of the most complete analytics platform that is available today. Okay, and it caters to all of the different personas as well. So be it the business users, the business analysts, the citizen data scientists, and even data engineers. So we have seen that we have capabilities for data preparation, data enrichment, data profiling happens automatically. Then for business analysts, you have the option to bring in additional data, not just data from a data warehouse, but say you have data because of the nature of your job and your role, right? You might have access to some other source systems in your enterprise itself, or sometimes you might have some third-party data which could be in files which you want to upload into the system, blend it with the existing data and come up with insights. So all of these capabilities are available as part of Oracle Analytics Cloud. So with this, I would like to end this cloud coaching session. Thank you for attending.